So let's move on to the lecture. And I think this is the last segment of PyTorch tutorial. And you also had a tutorial like hands-on experience today during office hours. So the final segment is model training. So first, let's quickly go over like the full training procedure we use to train your deep networks. The first step is you have to define your neural network. Then the second step is you have a training set. You will have to iterate over all the samples you have in your training data. Okay, so your network should see each and every sample in that set, and you do that in batches. So you will select like one batch at a time, and that's processed by your network. And then for each batch, when you process, you compute a loss. So that's like the fourth step. You will need to compute the network's loss, how good the network is doing. And depending upon how good the network is doing, which will be determined by this loss function, you'll have to compute derivatives of the network parameters, and that will tell you like how much you should shift like those values. So that will be like the backpropagation step. All right. And then once you have estimated like, okay, what should be the adjustment, you make that adjustment, which is called updating the weights. So let's go over like each of these steps in more detail. The first step is to define a neural network, and we covered that briefly last time, but I'm going to go over again because it's kind of connected. So in a neural network, you basically have two steps. One is forward, the second is going backwards. So forward is you have your data sample. That data sample is passed as input to your network, and whatever function you have as your network, so those transformations will be performed on the input. So all those transformations is called the forward function, or you can say like feed forward, which is going to give you predictions. Okay, so for this forward, you need actually a forward function, and we'll talk about like you actually need a class, and in that class you need this forward function, which will take the image as input or your data as input, and it will return like the output of the network. So this is actually the core of your network. Whatever functionality you have in your network is defined in this function forward. And of course, like whatever you're using in this function, you can have some helper functions for that. Okay, the second is backward. And again, this backward is the actual training when you update your weights. And the good thing is when you use these existing frameworks, you don't have to worry about it. So we have libraries which can automatically compute the gradients for us, and they can automatically update all the weights for us. We just have to call those as APIs. So the idea is, again, these are like some basic libraries you'll have to import. So you import Torch if you have to use those functionality, and then you have torch.nn, which is like neural network. And this is a very basic step, and you will always have to use this. So some of this will never change, whatever architecture you're defining, and some of this is like dependent upon what architecture you're defining. So we'll cover both. For example, like class, again, this is a Python keyword. You're just defining a class in Python. So it will have to be inherited with nn.module. Okay, so this will never change. We'll always use this argument. And net is just the name of your architecture. For example, we studied LXNet, right? So it could have been LXNet if you're defining LXNet architecture. So this is just a name. Then you should be aware of this because Python was a prerequisite. So this is just an initializer of this class. Whenever you will create an instance of this class, then this initializer is actually called. And again, you should know that. Okay, so and again, you're just calling the super. So again, this is the initialization of the inherited class. So again, this is all. It has to be there. It won't be changed. It's standard Python. And this is the most important function which we'll have to pay more attention to. So you can change the name as well, but again, it's good if you don't, because PyTorch assume that the name of the function is forward. But if you change the name, then you'll have to make some more changes to the code. But if you use forward, then PyTorch will automatically take care of this. It will assume that, okay, this is your network feed forward step. Okay, so this X is the parameter, which is like the input to your network. If it's an image, then X will hold image data. Okay, and in this function, you will define like how the transformations will be performed on this input data X. Okay, and we don't have to worry about backward.